Hey guys, I hope you all are doing good. So in the last lecture, we started with static arrays, and in this one, we are going to be continuing with the next topic, which is going to be 2D arrays, right? So by now, I hope you have a decent understanding of how arrays work, how static arrays work, and I hope that you have started with solving the problems as well on the C code, right? It's very important that from now on, whenever we cover some concept and theory, you apply it yourself as well, right? I will obviously be explaining the concepts on the board. For example, how traversal works, how the algorithms work on the board. I will also show the code examples on my computer as well. But important is that you implement it yourself once again, once the video is done or before any preparation, right? That's how you will actually get the idea of how these algorithms work. Okay, so let's start with 2D arrays, very important to understand. Um, a lot of use cases come from 2D arrays, so we need to make sure that we understand how 2D arrays work in a good detail, right? So let's start with understanding declaration and initialization. We're going to understand three important things: declaration and initialization, memory layout of 2D arrays, and then how do we access elements, right? So first thing is, basically it's an array of arrays, right? Let's try to understand what you're trying to say. Now the thing is, it's not usually that we just keep storing an array like this in just one complete sequence, right? You can do that, that's totally fine. But sometimes, let's say you're trying to arrange array in a 2D order. Why would you do that? Maybe you want to store some elements in a particular rows or columns, or maybe a tabular form, right? So whenever you're trying to store data in a tabular form, or when you're trying to create matrices, that's where 2D arrays come in play, right? So in your journey in CS, you're going to be using 2D arrays in a lot of places. So very important to understand, right? So basically an array of arrays. The visualization can be very simple. It's kind of like this, right? This is, you can kind of assume that this is a 2D array, right? So these horizontally are the rows, right? And vertically, if we look at these are the columns, right? So this would be one column, this would be another column, and then this entire thing would be a row, right? So rows are horizontal, columns are going to be vertical, right? The declaration is, this is how we declare a 2D array. So if you look at this example, right, when I say, so I'm using two different brackets in this case. If you remember, in a regular array, I was just doing something like this. So this was just a 1D array, right? Everything is stored in a one sequence, kind of like that. But when I declare like this one, right, what happens is that the computer is going to create three rows. This is the number of rows, and this is going to be the number of columns. So in total, I'm saying to the computer, right, that okay, I want you to create a 2D array with three rows and four columns, right? So if I try to draw it down, this is what it would look like. So it has three rows and four columns, right? So I hope you are able to understand it, right? Once again, why are we using 2D arrays? Why not just store entire thing in one array, right? The point is, whenever we come across a lot of data which is stored in tabular form, right? So maybe, for example, storing the data of a student. Maybe every single row you're using to store the data of a particular student, right? So in those type of cases, 2D arrays are what we use. So I've given an example of initialization as well. So this is how you can initialize a static 2D array, right? So if you look at this board, right, I've declared two different rows, if you look at it, and each of them have three different columns, right? So this is an array with two rows, three columns, and this is how they're stored, right? The first row has 1, 2, 3, and the second row has 4, 5, 6. So if I say print the elements in the row, how would you do it? I want you guys to pause the video and try to figure it out. So if you have to print the elements in the row order, you can just straight up print it. We're going to look at those examples in detail in the next part of the video. But for now, important to understand is that Rows are the horizontal sides, columns are the vertical sides, like this one, right? So the elements stored in row direction are going to be 1, 2, 3 in the first row, 4, 5, 6 in the second row. Column wise, if we look at it, then there's going to be 1, 4 in the first column, 2, 5 in the second, 3, 6 in the third, right? Okay, so I hope you're able to understand the declaration and initialization. Now, this might seem easy, but when we look at some important examples of accessing elements and traversal and many others, that's where things can get a bit complicated, right? But important part is that now the theory is very important to understand. So once you know the theory, I think it can get a lot more easier to implement algorithms as well. Okay. Next one is the memory layout of 2D arrays. So in C, 2D arrays are stored in a row major order. Okay, let's try to understand what is the row major order, right? Now think about this. This is what I'm telling the computer, or this is my visualization, I should say, right? What happens is that the computer is still storing everything in a single order. It's storing elements of the row first, then the elements of the second row, then the third row, then the fourth. So if I take a look at this example, right, what's going to happen is my computer is going to create an array of 6 elements. So it would have 6 elements in it, and the way they would be stored is first it would store 1, 2, 3, which is the first row, and then it would store 4, 5, 6. One important thing to clear once again is, look, the computer in the memory is storing the elements one after the other. It's creating the memory space one after the other, but this is for our help that we declare it and we can access it for our understanding. Right? Computer is still using just a continuous block of memory to store the values, but for us in our visualization, we assume that it's a 2D array, right? That's a very important thing to understand. So what's going to happen is first row is stored. This is going to be the second row, and that is what we call the row major order, meaning we store in the order of the rows, first row, second row, and whatever the third row is, etc. Right? So I hope you were able to understand this part. Once again, memory always stores in a contiguous order. And why do we store in a contiguous order? Point is very simple. We want to make sure that the access to the elements is very fast, right? Let's say I have an array of 500 rows and 500 columns, right? That's way too many elements. But I can still access them at a very good speed, and the only reason for that is because of this contiguous access, right? The computer knows that it's storing the elements one after the other, so it can access it in a quick way. Think about this in the other way, right? Think about if the computer was storing one element in some address, next element in some other address, which is way somewhere else in the computer, and the third address in somewhere, some other place. That would make it the traversal or accessing elements very difficult. Right? Think about going to multiple different places inside the computer to get together all the elements and then give it back to the user. Instead, and the other way, think about this way, the contiguous way, where you just have to go one step ahead every single time in the memory, and then you can find the element, right? So the reason for this kind of memory layout is very simple, so that we have a very fast access to our elements inside the 2D array, right? So quick summary once again, 2D and 1D arrays, they are stored like this in the memory layout, but the visualization is that in 1D arrays, every single element is in just one row, right? And 1D array is declared this way inside a C program. In any program, Python, Java, whatever you do, this is how you basically declare a 1D array, right? But 2D arrays are declared in this order. How do we access elements? In normal arrays, we can just enter the element. In 2D arrays, this is the row and this is the column. This represents the row, this represents the column. So we need to make sure that our visualization is clear and we know how to access the elements, right? So once again, this allows a fast access using the row major addressing, right? So I hope you were able to understand until this point. This is the equation of how you access a single element, right? I want you guys to try to pause the video and try to understand what this equation means. Okay, once again, let's try to understand one important point, right? So let's say I have this array, right? Let's say I have, let's say I want to access ARR. Let's say I'm trying to access matrix 2 1 2. Let's say I'm trying to access the matrix element row 1, element column 2, right? I'm trying to access this element. Now, this is going to be, the computer is not going to create a for loop for me and then try to look for this element. It knows exactly what the address is. What's going to happen is it goes to the base address, right? It's going to multiply I with the number of columns. So I in this case is 1. 1 multiplied by the number of columns. I have number of columns in this case is 3, plus it's going to do j, right? J in this case is going to be this value, 2. So this is going to be 1 multiplied by 3 plus 2. It's going to be the element 5 in this case, right? So this is the calculation. If you remember in the last video, I covered it as well. First, we add the base address, then we do this calculation. So it's kind of like this. Base plus whatever this value is. And that is going to give us the access to whatever element we have. Also, we need to make sure multiply this by the size. Okay. So I hope you were able to understand how the access works, right? And what is the declaration and initialization. Now, I might be going way too much into detail in such a simple concept, but I'm just trying to make sure that you have a deep understanding of what 2D arrays are, right? Okay, third one is very simple to understand. It's just accessing elements. So int val equal matrix 1 2. So this is just like how do we access the elements, right? And this is how you can update an element. And if you want to traverse a 2D array, once again, that's very important to understand. I want you guys to try to pause the video and then try to figure out that if I give you a 2D array, how would you print all the elements in it? Okay, so the answer is very simple. You would create this is kind of what you would do, right? I would have to first create a for loop and then a nested for loop. And in the first one, I'm trying to access the rows. In the second one, I'm trying to access the columns. And then how do I print the elements? I can simply do. So think about this, right? Just let's try to understand this, what's exactly happening. My first thing, my loop enters the first for loop, which is using the value I, right? Inside each I loop, I should say, there's another for loop which goes until the end of the columns. So what's going to happen is first we go to 0 row and we check every single column. We print every single value in the first row, and then we go to the second row, then the third, until the very end of the rows, right? That's how this for loop is working. Now, this basic structure is very important to understand to make more complicated algorithms, which we're going to be covering in the next part. Right, so I hope you were able to understand how 2D arrays work. Very important to understand. And now let's take a look at a few examples. Okay, hey guys. So now this is an exercise for you. First, I have given some questions on the board. These are program questions. I want you guys to solve all of them. Like just write a C program and then check if they're working or not, right? So once you're done, then I will solve all these 3 questions on the board, and I will also give the code as well in the video, right? Okay, so I'll give you guys a quick overview of what the questions are asking. So the first one is print the row-wise and the column-wise sum. Let's try to understand what it's saying, right? Let's say I have a matrix like this. One more thing, one thing that I forgot to mention is that once again, the elements always start at 0, right? So when you declare an array like this, definitely means that this has 3 rows and 4 columns. But the point is, the way you access the elements is still going to be 1 less than the last one, right? So if I want to access the last element, which is 3 4, it should actually be like this. This is where the actual last elements will be stored. Once again, why? Because elements in C, the row, or I should say the array, start at the index 0, right? Okay, so now let's take a look at this example, right? What's it's asking? So the question is saying print the row-wise and the column-wise sum. The task for you is, let's say I have the elements stored like this. What I want you guys to do is print the row-wise sum, right? Which is print the sum of the row, this one, for example, row 1, row 2, sum. And once you're done, I want you guys to print the sum of the columns as well. So columns would be, this would be sum 7, this would be 9, this would be 11, this would be 13, and this would be 15, right? These are the sums column wise. The row wise sums would be 1 plus 2, 3, 6, 10. This would be 15, and I hope you understand what I'm trying to say, right? So this is what I want you guys to do. Second one is print the sum of the diagonals, right? Decide to understand what this question is asking. So in the diagonals, I'm basically asking about the diagonal elements. So if you have a 3 by 3 array, diagonal elements would be the element over here, in the center, all these positions and these positions, right? Basically like a cross, I should say. Okay, and the last one is transpose a matrix. Transpose a matrix basically means flipping the matrix. So I can give you guys a quick tip for the question as well. What you're basically supposed to do is, if you have an element at position ij, you're supposed to flip it and change it to the position ji, right? So these are the 3 questions on the board. I want you guys to take your time, solve these questions, and then I'll try to explain them on the board. Okay guys, I've written the answers to all 3 problems on the board. I'm sorry if it's kind of messed up, but I'll try to explain everything that we have done, right? The reason that I'm not explaining using the computer is because it's a lot more difficult to explain. I can just move the arrow around and basically not do anything else. So I think it's more clear for me to explain on the board because I can draw the diagrams and explain it, right? Okay. Let's start with the row column sum. So just like I said, the problem was print the sum of the rows and the sum of the columns as well, right? Now the problem is, how do you access the rows, sum it up, and then print it, right? So let's take a look at how do we print the sums of the rows, right? I want you guys to take a look at this code first. Try to pause the video, try to understand it, and then I'll try to explain. Okay, so let's try to understand what's exactly happening, right? First thing is I create a loop. I go until the end of the rows, right? So my first loop is to go until the end of the rows. How many number of rows I have. So second thing is I have declared this row sum. So I'm saying this is where I'm going to store the sum of every single row, right? I've created just one row sum value, and this is what's going to help me store the sum of each row, right? Okay. Now, if you notice in the next one, I've created another loop which is going until the columns, and I'm doing j++. Inside that loop, I'm doing a row sum plus equal the whatever the matrix is, ij. Let's try to understand what's exactly happening, right? Okay. So this is what my array kind of looks like. It's 2, 3, meaning I have two rows and I have 3 different columns. Point is, this one is printing the sum of the rows. So let's try to understand what's exactly happening, right? This one is going to each row, right? This for loop So first thing is it's going to go to the row 0, right? This in the other for loop inside it is going to go to each and every element inside it. So let's say my first row stored 1, 2, 3, right? First for loop goes to the row 0. Second for loop goes to each position. First goes to 0, 0, then 0, 1, then 0, 2. And then I store whatever the sum is inside this row sum. So what happens is first row sum is equal to 1 plus 2 plus 3, which results in a 6. This is what's going to happen in the first iteration, in the sum of the first row, I should say. And then if you notice, I've given this print statement, right? It's going to print the value, which is sum of the row. Person D, I hope you understand the C syntax. I'm simply saying that the sum of the row 0 is whatever the sum comes out to be, right? Now, what's going to happen is it's going to print something like this. Sum of row 0 is 6. And in the second for loop, it's going to go into the first loop again, right? Once this loop ends, it's going to go into this one again, which means it's going to the first row now. Let's say it has elements 5, 5, 5, right? Going to this loop again, inside it's going to add all the values at each column, right? So go to this row, add 5, then 5 at position 1, then 2 again, which kind of gives me 5 plus 5 plus 5, which is going to be 15. Once again, once it knows that it has reached the end of the columns, it's going to print it, right? So pretty simple code. I hope you were able to understand it. Now, it might seem like this is way too simple, right? But I've seen that in a lot of the cases in my personal experience as well, even these basic things are where I've made a lot of mistakes, right? Sometimes what happens is that when you're making a program, or let's say you're writing an assignment or a project, um, these are some of the places where you might have created bugs and you might have missed some stuff, and you've messed up kind of how did you access the matrix elements and stuff like that, right? So having a very good understanding about the basics is super important to debug these type of problems. Okay, so I hope you were able to understand this. Now think about the column one, right? Let's try to understand this. What I've done is I've done the exact opposite. Point is, if you try to visualize or try to think about this, right? How do I print the sum of all the columns? My first thing is I have to go to each and every single different column, right? Which means my first for loop should be going to different columns. Inside that, the nested for loop is where I should be going to the different rows. So if you look at the row sum one, right? I was first going to each row, then going to each element inside it. But now in this case, I have to go to each column and then go to every single element inside that particular column. So how do we do it? First, so if you look, I flipped the loops, right? In this case, it was the rows. In this case, the first loop is the j less than quotes column. So that basically means that we are first checking the columns. Second, I've again declared a call sum variable. Third, now inside this loop, we check the rows, right? Once again, what this means is first go to this column and then go to a particular element inside that column. That's what this code kind of represents, right? Okay, so we go to the element, we go to the column, I should say, we add the sum, and then we print the sum of that column. So first it would print something like 6, then 7, then 8, right? So that's pretty much it for the printing. This is to give you guys a basic idea of how do you access the elements of a row, how do you access the elements of a column. The basic applications could be, let's say somebody asks you to store, let's say you store elements in a row wise order, then and you're asked to print it or store it in a different place, then this is how you would exactly do it, right? Okay. Now let's try to understand the sum of diagonals. How do we do it? Once again, just one important thing is you need to assume that the number of rows is equal to the number of columns, right? Meaning, let's say it's basically going to be either 3 by 3, 2 by 2, 1 by 1, something like this, right? But the number of rows is equal to the number of columns. So it's very simple to understand. What I'm supposed to do is, if I have something like this, let's say I have a 3 by 3 matrix, then I'm supposed to sum these values, then print it, and then sum these values as well, right? So cross the first diagonal, second diagonal, and the sum of both the diagonals, right? So I've given the code over here, but I've left this block. So I think let's try to understand what's exactly happening, right? I've created one for loop. I don't have to create other one because the number of rows is equal to the number of columns, and we are only trying to access the diagonal elements. Okay, so first let's try to understand what is the diagonal element, right? How do you access, what do you mean by the diagonal element in terms of a 2D array inside a C program? So think about this, right? If I have something like this would be 0, 1, 2, this would be 0, 1, 2. Let's take a look at what are the positions of the diagonal elements. This is the first diagonal element. position is 0, comma 0. This is the second diagonal element, position is 1, comma 1. This is the third diagonal element, position is 2, comma 2. I hope this is kind of making sense, right? Do you see the pattern over here? The point is, in all the diagonal elements, the I is equal to the j. So how do I basically print out the diagonal elements? I can just use the values I, right? So think about this. First diagonal element would be 0, 0, then 1, 1, 2, 2, 3, 3. So doesn't matter how big my matrix is, the diagonal element is always where the row is equal to the column, right? So this is exactly how I'm doing the diagonal 1 addition. So this is the, I should say, left diagonal addition. Diagonal 1 is equal to matrix I, comma I. What this means is, first element 0, 0, then 1, 1, then 2, 2. Sum it up and that gives me the sum of the diagonal 1. Okay, now let's try to take a look at the other diagonal and try to understand its concept. Okay. Now, very important thing to understand is, right, whenever you come across these type of problems or algorithms, it's very important that you try to kind of visualize what exactly is happening. Point is to figure out some kind of a pattern in the question, right? Just like in this one, in the sum of the diagonals, I need to understand what is a diagonal element, and then I can kind of figure out how am I going to print out the sum of it. Okay. So printing the sum of the first diagonal was very easy, but what about the next one? Let's try to understand the pattern in this diagonal, right? In this diagonal, the first element is 0, 2. The second element is 0, 1. Third element is, second element is 1, 1. Third element is 2, comma 0. Okay. Now, try to understand this pattern, try to pause the video and then try to figure out what's exactly happening, right? And then I'll try to explain how to print it. Okay, so in the last one, in the first diagonal, right, I was simply doing I, meaning 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? It's going in this direction, very easy to print. But in this case, look at the pattern of the diagonal elements. The first diagonal element is 0, 2. Second one is 1, 1. Third one is 2, 0. So if you look at it, the rows, the first I is going in the right direction, 0, 1, 2, and I should say in the ascending order, but the next element is going in the descending order, right? So how do I do it? I can traverse the rows using just I, because rows are just going in the correct ascending order. But for the columns, right, I'm going in the opposite direction, meaning I have to start at the last one and then come back to the first one. How do I do it? I simply do 2 minus I. Or in this case, I can say it should simply be rows minus I, right? What does this mean again? This is basically saying that, okay, I'm in terms of rows, I'm supposed to go in the ascending order, start with 0, go up till the end. But for the columns, I need to go in the opposite direction, meaning start with last and then go back. It's because it's going 2, 1, 0, right? So this is what I'm doing. I look at all the number of rows and then subtract I to it. And this is how I can access it in the descending order, right? So try to implement this in your code as well in your computers. But once again, at the end of the video, I'll give the code for these problems as well. Okay. Now let's take a look at the last one. Transposes, I gave you a very quick overview. This is a very simple problem. You're just supposed to flip the i's and j's. So if you look at this, let's say I've declared this transpose 3, 2, right? I've created two for loops, two nested for loops. First, I go to the rows, I consider the rows, then the columns. And then if you look at it, all I do is I set transpose ij is equal to transpose ji, right? That's pretty much it. That's all you have to do. And that's it for this lecture. Now I'll be giving the code for these problems, right? One more thing before I end this video, all this code can also be implemented in other programming languages as well. So it doesn't matter whether it's Python, Java, or any other C++ or C sharp. Point is that you should understand how the code is working. You should understand how to recognize the patterns that we are using, right? Once you do that, you can pretty much implement any code in any language. It's just that there are differences in the syntaxes of different languages, right? So once you understand this code, I'm pretty sure that it can be very easy to implement it in the Python code as well. For now, since these problems are very small, I'm going to be implementing the code in C, but as the problems get way more complicated, we will move on to the Python language. Okay, guys, let's look at the code. So this is the C code for it. First of all, we have defined the 2 by 3 matrix, right? And first, this is just a general flow so that you understand what's exactly happening. First, I've displayed the matrix. Second, I'm doing a row-wise and the column-wise sum, right? So just like I explained in the video, right? Row-wise sum, you have to correctly make sure that you're adding the right values, and you have to make sure that the indexes you're giving the ij values are in the correct order, right? Second is the column-wise sum. Third, this is just the 3 by 3 square matrix for the diagonal calculation. So just like I said, diagonal 1 would be II and diagonal 2 would be I, but for the second one, we have to subtract it from the number of elements minus I, right? Okay. Third one, we are displaying the square matrix again. And the last one is just computing the transpose and displaying it, right? So I'll show you a working example of this as well. I've already compiled the, I should say the executable for it. So I'm just going to do /a.out. Once again, if you have a doubt in understanding how to run C code, I think there are a lot of examples out there, but just to give you a quick overview once again, this is how you do C code. And then and this is basically like the C code I use for compiling my C code. Maybe you can use other compilers as well. Maybe you can find it online, but this is how exactly I do it. And this function, I explained this in the video as well. This is created like an executable, which the computer architecture can run now, right? So this is going to be, right, so this is exactly what's happening. So first we print the original matrix, the row-wise and the column-wise sums, the sum of the diagonals, and then the transpose, right? I can give a link for the GitHub as well, and that's pretty much it for this lecture.